Hey friends, so we're going to go ahead and get started on section 1, topic 5, which is one of the more difficult topics we've looked at this year, so it's exponents and radicals. So in topic 5 is just focusing on exponents. So I first want to look at number 1. Number 1, all 3 parts, you're just simplifying the expression. So any sort of operations we can do to make it more simple is what we want to do. So if we look at part A, I'm first going to do the coefficients. So 2 divided by 4 is going to leave us just with the 2 in the denominator because those can just be simplified by dividing by 2. You could have that 1 in the numerator, but I'm going to leave it alone. And then we have x to the third, y to the third, and then y squared in the denominator. That's not all we can do, though. We have y values, and anytime you have the same variable, you can combine their exponents in whatever operation. So if we're dividing things with exponents, in case you don't remember, you subtract their exponents. So right now I have 3 minus 2, so I still have that x cubed in the numerator, but now I just have a y because that and that leaves that with a 1, and then a 2 in the denominator. So that is how simple we could get part A. Part B, so in part B, we're raising an exponent to an exponent. So when we do that, we want to multiply. So for the and we want to apply this negative 2 to the numerator and the denominator. So negative 8 times negative 2 would give us x to the positive 16th. And then 11 times negative 2 would give us y to the negative 22nd. And we actually can't leave it like this because when you're raising something to an exponent, you're talking about how many times are you multiplying it by itself. Well, when it's raised to a negative number, you can't multiply something by itself negative 22 times. So what we need to do is we can take this entire thing and we can move it up to the numerator. So that would leave us with x to the 16th power. And then instead of y to the negative 22, because we moved it to the numerator, it's now y to the positive 22. And that's our final answer on that one. And same thing, if you had a negative exponent in the numerator, you would also make it positive and move it to the denominator. And then in part C is more of a multi-step problem. So the first thing I want to do is apply this 2. That 2 is only being applied to the x to the 4th power. So if I simplify that, I still have 2x to the 3rd times x to the 4th squared. We multiply those exponents to get x to the 8th, and then 8x to the 11th. And what we could do now is we could add these 2 exponents, x to the 3rd and x to the 8th, because remember when you multiply things with exponents, you add them. So that would give us 2x to the 11th over 8x to the 11th. And you'll notice we have an x to the 11th in the numerator and the denominator. So those could divide and equal 1. So, and then we could simplify this 2/8, and that final answer would simplify to just 1/4. All right, so let's look at number 2. Number 2, your neighbor has a square-shaped pool with side length 3a to the 5th power. What is the area? So the first thing I would do here is draw my pool, and it tells me that's a square, so I know that all the sides are the same. And if we're finding the area, we want to multiply the length and the width, or the base and the height. So if we multiply these together, we could write it as 3a to the 5th times 3a to the 5th, which is fine. But just another way you could write this is 3a to the 5th squared. So we want to multiply those 3's, those coefficients together to get 9. And then we want to add those a's together. A to the 5th plus that a to the 5th would give us a to the 10th. Okay, number 4 is the next problem I want to go over. So again, it's in 3 different parts. And what it wants me to do is find the value of m. So it kind of gives us an equation, and we have to see what's happening to the exponents to figure out what that missing value is. So if you look at this first one, you'll notice that our x values ended up being 21 in our final answer. So over here, I'm going to end up multiplying these by 3. Well, my question is, what number times 3 is going to give us that answer of 21? Well, that's 7. And I already have x squared here. So what number plus that 2 is going to give me that 7? And that would be 5. So it's kind of like a little bit of a work backwards. Okay, and same thing goes with number 2. So you'll notice that my x value at the I'm looking at my z value. My z value at the very end doesn't have an exponent, but it does. It's that imaginary 1. So right now I have a z to the negative 5 in the denominator. And I want to know what number minus negative 5 is going to equal 1. So remember, if we have minus and negative, that's going to change to a positive, and we want to subtract that over. So that's actually going to end up being negative 4 for that m value. And the last one, what number would that m have to be for that entire equation to equal 1? Well, that's a rule that we learned. I know it was all the way back in September, October, but anything to that 0 power is going to give us an answer of 1. All right, and then the next problem I wanted to look at is number 6, and it says the dimensions of Peyton and Parker sandbox are t squared meters by t to the 5th meters by 3v squared meters. And 1 cubic meter, it contains 3s to the 21st power grains of sand. So the first thing I want to do is find the volume in meters of this sandbox. So we know one dimension is t squared, the other dimension is t to the 5th, and then the third dimension is 3v squared. So how we would find the volume is just multiplying all of those together. So t squared and t to the 5th would give me t to the 7th. So we have 3v squared times t to the 7th power. Now that only gives me the measurement of the box. We want to know how many grains of sand can be in the box. And so we need to multiply this by the amount of grains of sand in 1 cubic meter. So if we multiply the coefficients 3 times 3, that would give me 9. And then none of the other variables are the same, so we can't really combine those. So we just want to list the variables. So we have v squared, t to the 7th, and s to the 11th. And that looks like, or sorry, it's not the 11th, it's the 21st, excuse me. And that looks like letter D. Okay, and then the last problem I want to go over is number 9. So number 9 says Raymond and Rose are working with exponents. Raymond claims that 5 to the 5th times 5 squared equals 5 to the 3rd. Rose argues that 5 to the 5th times 5 squared equals 5 to the 7th. Which one of them is correct? Well, remember when we're multiplying, we want to add the exponents. So it looks like Rose did that correctly because she added 5 and 2 to get 7. Raymond did the opposite, which is what we use for division. So Rose is correct because say something about when you add exponents when multiplying. And then part B is kind of the opposite. So Raymond claimed that 7 to the 9th divided by 7 to the 5th equals 7 to the 4th, and Rose argued 7 to the 9th divided by 7 to the 5th is 7 to the 45th. Which one of those is correct? Kind of the same reason. Raymond is correct, and that is because you want to subtract your exponents when you're actually doing the property of division. Again, if I didn't go over a problem you had questions on for this topic, just send me a remind text or an email, and I'll get back to you as soon as I can. Bye, guys.